Thanks to NordVPN for sponsoring this video. Check out the link in the description to learn more, and stick around to see how you can score a sweet deal. Alright, the first thing I'm going to do is mosey on over to the movie clip editor, open up my source footage. I'm going to prefetch it so that it plays smoothly, and set the scene frames so that the length of the scene matches our footage. So the first thing we're going to need to do is camera track the scene, so that we can put 3D objects inside of it and have them stick in the right spot. We're going to be making use of Blender's camera tracker, and there's a little bit of setup we need to do. Over in the tracking settings, we can set the settings that will be set for each tracker we set. There's a lot of flat surfaces in this scene, so I find that the perspective motion model works best. And for some reason, matching the previous frame just works better. I'm going to control-click on my footage in an area of high contrast to add a tracker. Areas with lots of details and high contrast are easier for Blender to track. Now I'll press Ctrl-T to start tracking. You kind of have to baby it sometimes and change the track every once in a while if it's having trouble, but generally it does a pretty good job. Now I'm going to go through the rest of my scene, making sure to track objects through various depths in the scene. We want tracks in the background, the foreground, on each wall, just to give Blender a broad idea of the movement of the camera. If one of your trackers is momentarily obscured by an object, you can just move forward in time until it's not obscured anymore, move it over to its original position, and keep tracking. Now that we have a solid amount of tracks in our scene, let's mosey on over to the Solve tab. Here we're going to set 2 keyframes. These are basically like reference frames for Blender to tell the depth of your scene. So try and pick 2 frames that have a change in perspective between them. I'm not entirely sure what it's actually doing, but I usually get better results if I select all the options for Refine. Let's smash that solve button, and it looks like we have a solve error of less than 1, which is what we're going for, so we're good to go. Let's move on. Blender has a nifty little feature called Setup Tracking Scene. Just go ahead and click that, and it'll bring your tracked camera right into your scene. Now if I hit play, you can see we have our footage set as the background, and the camera is properly tracked in there. However, the floor is totally not pointing the right way, so let's fix that. Back in the movie clip editor with our camera track, there's actually a feature where we can select 3 different trackers, and that'll pretty much fix our problem automatically. So I'm going to go ahead and add a couple trackers to the ground, track them for a little bit, and then resolve the camera. Now with my 3 ground trackers selected, I can hit floor and we're good to go. Back in the 3D view, our camera is clipping through a cube, so let's delete that. But if we play it now, you can see that our ground is correctly positioned. However, it'll make our job easier later if we have the axes of the ground matching up with the lines in the scene. So I'm going to go ahead and rotate the camera from the 3D cursor so it lines up. Looking good, baby! Okay, moving on. Let's bring in our random human head 3D model that we're going to be using. I'll have the link to the one I used in the description. Now I'm actually having a hard time matching this up to Riley's head position in the scene because I don't have any reference for how big or how far away from the camera this head should be. So let's make some reference by creating a 3D representation of the walls in our scene. I'm going to do that by going back into the movie clip editor and under the geometry tab, converting them to a mesh. I'm going to do this with both walls. Back in the 3D view, I'm going to use these for reference as to where to put my walls. Trying to see around these walls the whole time we're working is going to be annoying, so I'm going to go up into the view options and turn on backface culling so that it only displays the front side of the wall. If your wall's facing the wrong way, go into edit mode, select the face, hit N flip to flip the normals. Now I'm going to give myself a bit more reference by going into each wall, adding some loop cuts, and extruding certain parts of the wall so I can more easily tell where to place my objects. However, now we got these freaking walls covering up our background footage, so I'm going to go into the object properties for each object, and in the viewport display settings, I'm going to display it as wire. So now we'll be able to see through the mesh. Now I'm going to bring back in my head 3D model and roughly match it to the size, location, and rotation of Riley's head. Next, I'm going to go into edit mode and enable proportional editing. After using the page up and page down keys to change the radius of the proportional editing, I can drag the vertices into place so that they correctly match up with his collar and the outline of his face. Now, I'd like some finer control over the animation and movement of this head, and I'm going to do that with an armature. So I'm going to add in an armature, go into edit mode, and extrude the bones so that they match up with the neck and the head. Now I'll select the head mesh, shift-click on the armature, press Ctrl-P, and select Armature Deform with Automatic Weights. Now if we go into pose mode with our armature, we can control the head with the bones. Ain't that nice? Next step is to turn on automatic keying and make our way through the animation, adjusting the neck bone's position and rotation to match the actor. I used a mask modifier and hid the head to make this a little easier. It's a bit of a pain, but it's definitely worth taking the time to get an accurate track on your actor. Because if you got stuff drifting around, that's going to be the first thing people notice. Now, if we go into rendered view, you'll see that this looks like ass, which is fine. We just need to put some textures and material love into it. So what I'm going to do is project the footage of Riley's face onto the head 3D model. So that way, when we do a bunch of our gore simulations to the head 3D model, we still retain the original texture of Riley's beautiful face. So in the shader editor, I'm going to create a new skin material. I'm going to load in an image texture and select the frame of the footage in which Riley's head is going to explode. Then I'm going to press Ctrl-T to bring up some mapping options. If this doesn't work, go and enable Node Wrangler in your plugins. I'm going to change the texture coordinates to window. So now if we go into the material view and move around, you can see that we're projecting the footage of Riley's face onto this face. However, you can see that the texture doesn't stick to the object, which doesn't work great for us because when it's moving around, we want that texture to stick right onto that skin. So we're going to create a new texture. In the UV image editor, let's create a new texture. I'm going to call it skin. Then let's select that noggin, go into edit mode, select all the vertices, and press U Smart Project. This tells Blender where on the image to paint the specific parts of the object. So we're going to be baking the current texture of the object onto our new texture, and we have to specify what that new texture is. So back in the shader editor, let's bring in our new texture and make sure it's selected. The baking settings are in the render tab, so go there, and under the baking settings, we're going to be baking the diffuse and don't need the direct or indirect light, just the color. Make sure you got your new texture selected in the shader editor and smash bake. Now if we go back into the UV image editor, you can see we got our beautiful, terrifying new texture. Make sure to save it. Surprise, surprise, back in the shader editor, let's plug in our new texture and see how it looks. Beautiful, magnificent, terrifying, the worst. It's great. It's good enough for what we're using it for. Now, Riley's hair looks like it's painted on his head. Let's give him some real hair. Let's go into the particle settings, add a new particle system. I'm gonna name this hair. Let's change that to hair. And now we got hair everywhere, but we only want hair where it would grow on his head. So let's go into edit mode and select the faces of his scalp, of his scalp that's attached to his face. Select the vertices of the faces of his face where the scalp is. Over in the green triangle tab, let's create a new vertex group, name that, and hit assign. Now if we go back into our hair settings, we can scroll all the way down to vertex groups. And under density, select our scalp, so that our scalp vertex group specifies the density of the hair, so we don't grow hair on the other parts of his face. Let's make his hair a reasonable length and go into particle edit mode to give him a cute little hairstyle. When you're doing this, you might want to just text the person and ask them to send you a video of how they style their hair, because I got closer to Paul Dano than I did Riley. I don't know. Now if we go into rendered view, this looks horrendous. I'm going to fix this by going over to the hair shape settings and turning down the diameter of the hair follicles. And I'm also going to go over to the children settings and turn on interpolated children just to give it a bit more thickness. And right now the hair is using the same material as the skin, so let's go ahead and give that a new one. I'm going to make a new material slot, create a new material, and name that hair. The surface type I'm going to change to principled hair. And back in the particle settings, under render, we can change the material to hair. Now we can just go into the hair material, change the color and the roughness to suit our actor. Now if I look at this over my footage, it's still looking super janky, and that's because we need to match the lighting. And this is actually super easy. I usually just hop on HDRI Haven, which is a free website for HDR lighting maps. I'll search for one that roughly matches the lighting conditions of my scene. Here you can see I found one of an alley that matches that kind of top lit and blocked off sides lighting. Back in Blender, in the shader editor, I'm going to go over to the world shader. I'm going to bring in an environment texture and then navigate over to the HDR that I just downloaded. This HDR works pretty perfectly for lighting our scene, but you can always add in more lights or some black planes to subtract light if you need to. Now you can see if we switch back and forth between the footage and the new head model, the lighting is matching pretty well. Now that we have a solid representation of our actor's head in the scene, let's get on to simulating the skin exploding outwards. In the physics properties for our object, I'm going to enable cloth. This is how we're going to simulate the skin flapping around. I'm going to scroll down to the cache and just make sure that the simulation starts on the frame where we want the actor's head to explode. Now if we press play, Riley's head just falls straight out of the scene, and we can fix this by pinning certain vertices. Basically telling Blender to keep certain vertices in their original position and just simulate the other vertices. We can do this by going into edit mode and selecting the vertices for that neck. Then we can create a new vertex group, call it cloth pin or something, and hit assign. Now back in our cloth settings, under the shape category, we can set the pin group to the vertex group we just made. Now if we press play, his neck sticks in the right spot. However, his head remains one solid piece and we want it to break apart. So I'm going to go into edit mode and press K to bring out the knife tool. Then I'm going to draw some cuts along the object where I want it to split apart. Pressing V will separate the edge and disconnect those two parts of the mesh. Now if we simulate it, our head will break into a bunch of different pieces. However, it's more droopy than explosive, so I'm going to go ahead and add in a force field. After placing it where I want the explosion to originate from, and jacking the strength way up, if I hit play, you can see we got a nice fleshy skin explosion going. I'm also going to turn on self-collision so that it doesn't clip through the bottom of the neck. To give the head even a little bit more explosiveness, we can mess with the shrinking factor. This specifies how much your cloth will expand or shrink once Blender starts simulating. If we make this value negative, the cloth will expand right when we start the simulation, which will emulate the skin being blown apart. I'm pretty happy with how this is looking, so in my cloth settings, I'm going to mosey on down to the cache and hit bake. This will fully simulate and save our simulation. The simulation came out kinda jagged, so I'm going to go into the modifiers and add a smooth modifier just to smooth out the geometry a bit. To finish out the skin, I'm going to give it some thickness and then add a fleshy material to the inside of the skin. Then we're going to displace the geometry of that fleshy material, so it seems like there's some chunks of flesh still stuck to the skin. We're going to be doing this all through a series of modifiers, which we will set up now. First is a solidify modifier, just to give it a bit of thickness. And we can actually set the material of the new geometry we're adding under the material settings. This uses a material offset number, which corresponds to the material slot of your object. So if it's on 0, it'll correspond to the first material slot. And we already have 2 taken up. So I'm going to add another material slot, give it a new material which I'm going to name Skin Inside, and then set the material offset of the Solidify modifier to 2. Now I just have a very simple red shader applied, and I'd like to make this look a little nicer. So let's open up the shader editor. I'm going to add a noise texture so that we can have some variation in the color. Gonna mess with the scale and distortion until we got something nice. Then throw a color ramp in between that and the principled shader. I'm going to give the color ramp a couple fleshy colors. Then I'm going to use this to drive the roughness of the texture. We can dial this in a bit further by adding another color ramp and crunching those values until we have some areas of roughness and glossiness. We can also use this texture to drive the displacement, which will add detail at no render cost. To make this work right, you gotta throw in a displacement node and then plug the texture into the height value. It'll be way too much, so throw a math node in between those, set it to multiply, and bring the value down until it doesn't look insane. Adding a little subsurface scattering will let light bleed into the flesh, similar to when you shine a flashlight through your hand and you can see the light coming through. This is the setting for that. Then plug the color of your flesh into the subsurface scattering color, and we got ourselves a pretty good flesh material. A cool feature they added to Solidify in Blender 2.9 is outputting vertex groups. This will spit out the vertex data of the new geometry you're creating through the Solidify modifier, and we can use this data to drive a displacement modifier which will make it look like there are little chunks of flesh hanging off the skin. So I'm going to go ahead and add a new vertex group and call this Solidify Shell. Back in the Solidify settings, we can set the output vertex group of the shell to our new vertex group. Now we have a vertex group which is going to spit out only the vertices of the flesh inside the skin. It's going to leave out the geometry of the skin, so that when we apply our displacement modifier, we're only displacing the inside of the flesh and leaving the outside untouched. So let's go ahead and add that displacement modifier. We can create a new texture and set the vertex group to our new vertex group. Now if we mess with the strength, you can see that it's only affecting the flesh. In the texture settings, I'm going to name this new texture Flesh Displace. Then let's go with some clouds. Now you can see it looks like our flesh is clipping through our skin, and there's actually a really easy way to fix that. Just go down to the color settings, turn on color ramp, and add a new color thingy. Then delete the black color thingy, and you're good to go. Now our flesh is looking pretty low poly, so I'm going to add a subdivision surface modifier, and place that before the displace modifier, so the displace modifier has some geometry to work with. Back in the texture settings for the texture that's being used by our displace modifier, I'm going to screw with the size until I get something that looks nice. Now that that's finished, if we hop on over to rendered view, you can see that we have something that looks pretty nice and gross. I'd say this is good to go. Let's move on. Now let's add the skull. I'm going to bring in a free skull model I downloaded. I'll put the link to it in the description. I'm going to scale it down and rotate it so it looks right. Then parent that to the bone so it follows the head movements. Now our skull sticks in the right spot when the head moves around. Now this skull is looking pretty clean, so I'm going to paint some blood onto it. In the UV image editor, let's save a copy of our skull texture so we can keep the original. Then I'm going to go into texture paint mode. If you hit N, that'll bring up the tool settings, and I'm going to scroll down to texture and add a new texture. In the texture panel, I'm going to name this blood brush. And hopping over to Google Chrome, I'm just going to do a quick search for a blood splatter texture. Make sure to find something with a transparent background and save that. Back in the texture tab, I'm going to import my new blood image. And now we can paint with the blood, but it's pretty jacked up. So in the texture settings of the brush, I'm going to set the mapping to view plane. Then in the stroke settings, I'm going to turn up the jitter a little bit. Now I'm going to work my way around the model painting blood as I go. If you want some variation, in the texture settings, you can change the contrast and brightness. Once you're finished, make sure to save the image in the UV image editor and we're ready to go. I'm pretty happy with how this is looking, so now I'm going to break the skull into a few different pieces. First, let's separate the jaw by going to Edit Mode, selecting all the vertices of the jaw and its teeth, and pressing P, Separate by Selection. Now let's select the top half of the skull and hide everything else. I'm going to create a new cube. This is going to act as our cutting object. Over in the modifiers for the cube, I'm going to add a subdivision surface to give it some more geometry. Then I'm going to create a displace modifier, add a new texture, and call that Boolean displace. In the texture settings for that texture, I'm going to set it to clouds, and then mess with the scale until we get something nice. Back in the modifier settings, I'm going to turn down the strength of the displace modifier until it's not going crazy. Then I'm going to apply all of these modifiers to the mesh. Next on our skull model, I'm going to add a Boolean modifier and use the eyedropper to pick our new cube. Now our cube should be cutting out the parts of the skull that it's overlapping with. We could just hit apply now, but we want both the top half and the bottom half of this piece. So I'm going to duplicate this mesh, then apply one of the Boolean modifiers, click on our duplicated mesh, switch the Boolean to intersect, and then apply that. Now you can see that we have two perfectly cut out pieces of our skull. However, the inside of the cut has some janky UVs, so I'm going to go into edit mode for each piece, press Ctrl I to invert the selection of vertices. Then press U, project from view. Now in the UV image editor, we can move around these UVs until it doesn't look janky anymore. Do the same with the other piece of your skull, and bam, we got some good skull pieces ready to animate. Alright, next step is to have the top half of our skull blow into different chunks. So I'm actually going to be using the Cell Fracture add-on for this. And to make sure you have it, just go up to Edit Preferences, go to your add-ons and search for Cell Fracture, make sure it's enabled. But Cell Fracture is going to break our object into a bunch of different pieces, and the inside of those pieces aren't going to have correct UVs, and so the textures are going to look displaced and weird, and we're going to have a bunch of white borders and random crap in there. So we want to give the interior of the skull a new material. So in the Materials tab, let's add a new material slot, and now we're good to bring up Cell Fracture. If we hit F3 and search for Cell Fracture, we can bring that up. And for the settings, we can set the point source to the object's vertices, turn up the noise a bit, make sure to set the material slot to 1, because we want to give the inside of the skull a new material, and hit OK. That is looking good. So now we can take our original skull, move it over, and turn off display and render so we don't see it anymore, but it's still there. Now I'm going to dial in the look of the skull pieces. So I'm going to go into rendered view, and in the shader editor I'm going to once again add a noise texture, throw in a color ramp in between to give it some variations in color, give it a mix of bone and blood colors. Same process, plug it into the roughness and dial that in, then plug it into the displacement, throw in the displacement node and the multiply node and dial that in until it looks good. And we're good to go. Now we want to do a physics simulation on this head, and since these are solid, non-squishy pieces, we are going to be doing a rigid body simulation. So we can select all of the brain pieces, hit F3, and search for rigid body, add active. Active rigid bodies are the parts of your simulation that will be moving, and passive are the ones that won't, like the ground and the walls, etc. Now if we hit play, our brain pieces just fall to the ground, which isn't what we want. We want more of an explosive effect. So I'm going to hit Shift A and add a force field. And you're really only going to be able to see the effects of this force field if you jack the strength way up. So let's do that, and then you can see that we have a nice brain explosion going. However, after that initial burst, the pieces of the brain still continue to accelerate. So I'm going to place a keyframe for the strength so that the force field starts out very strong and then over the next few frames dwindles down to a strength of 0. So a few frames later, I'm going to set another keyframe for a strength of 0 by pressing I over the strength value. Looking good. Now, it wouldn't be a head explosion effect if we didn't have a little brain squishing around in there. So I'm going to grab a free brain 3D model and import it into Blender. Let's align this little sucker with our head and then go into the shader editor to give this a new material. I'm going to follow the same process as before, using noise textures and color ramps to give this a nice, fleshy, gross texture. Here are the nodes I used if you want to go the same direction. After parenting it to the head bone, I'm going to go into edit mode and select the vertices we want to use as the pin for our soft body simulation. I'm going to create a new vertex group and hit assign. Now in the soft body settings, under goal, I'm going to set the vertex group to our new vertex group. Make sure under strengths to set the default to 1. Now our brain will stick in the right spot, but it's pretty droopy. So we're going to need to add some bending. Bending specifies how much the mesh will try to keep its original shape during the simulation. Another little touch I like to add is an eyeball hanging off the head. So I'm going to go over to Blend Swap and find a free eye 3D model. I'm going to bring that into Blender and change the position, scale, and rotation to match the scene. I'm going to model a super rough eye holder flesh piece. I'm pretty sure this is not anatomically correct, but it gets the point across well enough. I'm going to create a new material for our eye holder using the same techniques we've been employing thus far. But for this one, I decided it might be interesting to have some kind of rings going around it, so I added a mapping node to the noise texture, and I messed with the scale until I had something looking nice. Then I went ahead and finished up the eye holster material. Here are my nodes if you'd like to take a look. I also added a displacement map with the noise texture to give it a bit of bumpiness. Then I'm going to add an armature, and in edit mode I'm going to extrude it into several pieces so that we can pose our eye and its holder. I'm going to select both the eye and the holder, and then shift select the armature and press Ctrl P to parent with automatic weights. Now I'm going to reposition the eye so that it's in the right spot, and then shift select on our head armature, and in pose mode I'm going to press Ctrl P to parent it to the bone. Now I'm going to turn on automatic keyframing and make my way through the animation, posing the root bone of the eye first. I'm going to eyeball this and try and mimic what physics would be doing to the eye holster. Once I'm done with that first bone, I'm going to move on to the second bone, and since we want this to be a little floppy, I'm going to basically mimic the same movement of the root bone, but delay it a little bit, so that the second bone is kind of trailing behind the first bone, giving it the appearance of being loose and flesh-like. Now this is looking pretty damn good if you ask me, and the last thing I'd like to add is just some blood droplets spewing all over the place to really tie everything together. But before that, a quick message from our sponsor, NordVPN.
So if you don't know what a VPN is, a VPN provides you with a secure encrypted tunnel for your online traffic to flow. And nobody can see through this tunnel and get their grubby little fingers on your internet data. Hey, come on, let me in! Come on! Now, NordVPN has super fast servers, so it's less of a mineshaft type tunnel and more of a Lincoln tunnel type tunnel where your data is just flying right through there, left and right. Whoa! Jesus, they obviously don't know that with NordVPN, you can browse a different country's Netflix catalog, or any other entertainment website for that matter. I'm in the wrong lane. Please don't pull me over. Oh, it's a park ranger, we're chilling. Whoa! Speedster much? They obviously don't know that NordVPN has a 30-day money-back guarantee, so if they wanted to, they could be taking their time. Now, NordVPN also encrypts your connection while you're on the go, so if you're in the airport, using their Wi-Fi or in a coffee shop or anything, you don't have to worry about these creamy little data pirates coming and stealing your URLs. Excuse me, do you have a moment to talk about NordVPN? Excuse me, do you have a second to talk about NordVPN? I'm trying to help these people. I just want to tell them that NordVPN has a cybersecurity suite that can also be used as an ad blocker, so you don't have to get all these freaking pop-up windows. Did you know that? Excuse me. These people don't want to talk to me. Hey, excuse me. Hello, NordVPN. I have one more thing to tell you about NordVPN. And with Nord links, you get an even faster connection. And NordVPN doesn't even log your data at all. They're not interested in the weird crap you do on your computer. Hey, look, it's Clinton Jones. Hey, Clint. Clint, they have live chat through. They have 24/7 live support through chat and emails. Ren the Reaper just stole my parking spot. Hey Ren, did you know that NordVPN has 24/7 customer support through live chat and emails?
Through email as well? That's amazing.
Yeah, I know.
Dude, what amazing support.
It's
That's
crazy.
incredible.
It's amazing.
Wow.
This is like my 9th hour of telling people about NordVPN, and I just feel like I'm just not getting through to people. For some reason, they just can't. I guess they can't hear me. I don't know what it is. Yo, buddy. Hey, did you know you can have up to 6 simultaneous connections? You even get double data encryption for increased anonymity. Hey, I'm trying to tell you something. Hey, you get double data encryption, so you're for increased don't switch lanes. NordVPN was also selected as the best VPN in the Best VPN Awards for 2020. And that was by one of the most trusted experts, VPN Mentor. Whoa! I just wanted to tell you about the special Christmas deal.
Each purchase of a 2-year deal will get you 4 additional months for free. Go to nordvpn.com/PeterFrance and use coupon PeterFrance at checkout.
Whoa!
Now this is looking pretty damn good if you ask me, and the last thing I'd like to add is just some blood droplets spewing all over the place to really tie everything together. And we're going to be doing that not with a liquid sim because that would be a pain in the booty, so we're going to be using a particle simulation because it gets the point across without having to deal with hours and hours of babying a simulation. Nothing against fluid sims. They're lovely, but they're just a pain in the butt. Alright, so on our head 3D model, I'm going to go to the Particles tab and add a new particle system. I'm going to name this Blood. It's looking a little bit crazy right now because the scale of the particles is huge, so I'm going to turn that down a bit. And then we only want to start emitting particles once the head explodes, so I'm going to change the particle system start time to the frame in which the head is supposed to explode. I'm also going to change the end time so we get a short burst of particles and they don't continue to emit. Then I'm going to scroll down to the velocity settings and play with these values until we get something explosive. The normal value will eject particles out in the direction that the face they are emitting from is facing. Basically, it just makes them explode outward. For our particle, we're going to create a new icosphere with just one subdivision because we want it to be relatively low poly. I'm going to create a new material called Blood and give it a real simple, low roughness, high transmission red material. I'm going to rename this Blood Particle. Back in our particle settings, we can scroll down to the Render tab and change Render As to Object, and we can select our new object. We can change the scale to look not crazy, and then add some scale randomness for a little variety, and then jack up the number of particles as much as you'd like. For some reason, I got a little pee-pee stream of blood particles, but, you know, whatever. Go ahead and bake that, and we are good to go, baby. Also, at this point, I had kind of forgotten about the hair. Basically, just make sure the hair is at this point in your modifier stack. Then mosey on down to the hair dynamics settings and enable that, and then cache your hair simulation. After that, we're ready to render. After that was all rendered and done, I brought the footage into After Effects and did a super janky paint out of Riley's head. If you'd like to know how to do some actual good paint outs, make sure to subscribe because I'll be making a future video about that topic. And there you have it, a full head explosion effect right out of Blender, plus some compositing in After Effects. I hope you enjoyed this tutorial. It was a long one. I appreciate you sticking with it to the end, or I appreciate you skipping to the end of this video. Either way, you're a champ, and I hope you're having a great day, and I'll see you next time.
And finally, you're going to use the egg tool and select eat it.